if a nuclear war began tomorrow? What would really happen in the first 24 hours? It's the question that haunts our modern age. But the answer is more terrifying than most imagine. Because the war itself, the full-scale, global exchange of nuclear weapons, would likely be over in less than 90 minutes. Princeton University's Plan A simulation, a plausible scenario of escalation between the US and Russia, estimates over 90 million people dead and injured within the first few hours of the conflict. The war is the opening act. The real story is what happens in the 23 hours after the last bomb has fallen, and in the 10 years that follow. When we hear the phrase nuclear holocaust, we imagine the end of the world, an event that renders the Earth uninhabitable. But the planet itself will survive. The target of this war is not the Earth. It is civilization. Civilizational collapse is defined as a rapid, catastrophic breakdown of a complex society. It is a regression to simpler, often brutal, forms of organization, marked by social unrest and the loss of the systems that govern our lives. Even a small nuclear war, using a fraction of the world's weapons, could trigger this outcome through its cascading ecological effects. To measure a disaster of this scale, we cannot use traditional metrics for earthquakes or floods. The metrics that matter here are excess mortality, the number of deaths above the normal baseline, and the total vulnerability of our population, and, most importantly, our infrastructure. The threat is not just the blast. It's the loss of the intricate, fragile systems that sustain 7 billion people. Our greatest strength, our interconnected, advanced society, becomes our most profound vulnerability. How do we measure this threat? For 78 years, one symbol has served as our warning: the Doomsday Clock. First appearing on the cover of the Bulletin of the Atomic Scientists in 1947. It was created by the very scientists who had built the atomic bomb, but protested using it against people. It is a metaphor, a symbolic timepiece showing how close humanity is to destroying our world with dangerous technologies of our own making. Midnight is the point of annihilation. Today, the clock stands at 89 seconds to midnight. This is the closest it has ever been. The risk is now judged as greater than during the Cuban Missile Crisis, driven by a toxic mix of nuclear proliferation, the escalating climate crisis, biological threats, and the rise of disruptive new technologies like artificial intelligence. But this is not a countdown to an inevitable fate. It is a symbol of human agency. The clock's hands can move backward. In 1991, after the fall of the Soviet Union and the signing of the Strategic Arms Reduction Treaty, START, scientists moved the hands back to 17 minutes to midnight, the farthest it has ever been. The clock's hands are not moved by fate. They are moved by our policies and our failures. To understand the threat, we must understand the weapon. Early atomic bombs, like the one used on Hiroshima, were fission weapons. They release energy by splitting the heavy nucleus of an atom, like uranium, into two lighter ones. But modern thermonuclear weapons are hydrogen bombs. They use fusion, the same process that powers the sun. In this design, a fission bomb is used as the trigger. Its explosion creates temperatures of tens of millions of degrees, the force needed to fuse hydrogen isotopes together. The result is an explosion hundreds, or even thousands, of times more powerful. The 1952 Ivy Mike test was 700 times stronger than the bomb that destroyed Hiroshima. A full-scale nuclear war would unleash 3 distinct historical disasters, all at once. First, the Hiroshima effect. On August 6, 1945, a single fission bomb killed or maimed hundreds of thousands of people. It proved that in a nuclear attack, all first responders, hospitals, firefighters, aid organizations are simply unable to help. Second, the Chernobyl effect. The 1986 reactor meltdown was not a bomb, but it demonstrated the silent, invisible killer, radioactive fallout. It caused thousands of thyroid cancers in children and created profound, persistent, psychological and socio-economic trauma. And third, the Tambora effect. In 1815, the eruption of Mount Tambora in Indonesia shot so much ash and particulates into the stratosphere that it blocked the sun. The following year, 1816, became known as the Year Without a Summer. It triggered global crop failures, mass famine, and food riots. It was, as one historian called it, the last great subsistence crisis in the Western world. This is the blueprint for the real killer of a nuclear war. The threat is not abstract. It is deployed and waiting. As of 2025, 9 nations possess an estimated 12,241 nuclear warheads. This total number can be misleading. While it has declined since the Cold War, this is only because the US and Russia are slowly dismantling old, retired warheads. The military stockpile, the arsenal of usable, operational weapons, is increasing. Today, that stockpile stands at roughly 9,614 warheads. Of those, approximately 3,212 are deployed, meaning they are physically on missiles or at bomber bases. And of those, around 2,100 belonging to the US, Russia, the UK, and France are kept on high alert, ready to be launched on a few minutes' notice. This destructive power is not evenly distributed. The numbers are dominated by the 2 original superpowers. Together, the US and Russia control nearly 90% of the world's arsenal. But the strategic landscape is changing. China's arsenal is growing faster than any other nation's, projected to reach over 600 warheads in 2025 and potentially match US and Russian missile counts by 2030. This is creating a new, highly unstable tripolar world. The Cold War's 2-player mutually assured destruction was a stable, if terrifying, game. A 3-player game is exponentially more dangerous, dramatically increasing the risk of miscalculation and accidental escalation. A nuclear exchange would not unfold over days or weeks. It would be a compressed, cascading series of events. Phase 1. The first 90 minutes. Escalation. Many strategists have argued that a limited nuclear war using small, tactical weapons is possible. This is a fantasy. War game after war game, including Princeton's Plan A simulation, shows that once the nuclear threshold is crossed, control is lost. A tactical strike in Europe is met with a tactical reply. That reply is misinterpreted as a strategic assault. The escalation ladder is climbed in minutes, culminating in an all-out strategic exchange, targeting hundreds of cities and military sites. In this opening salvo, over 90 million people are killed or injured. Phase 2. The first 72 hours. The fallout crisis. For the tens of millions of survivors, the battle has just begun. The primary threat is now invisible. Radioactive fallout. Particles of debris and soil sucked into the mushroom cloud and irradiated, now drifting back to Earth. Official FEMA guidance for this period is simple and absolute. Get inside stay inside. The radiation is most lethal in these first hours. All hospitals and emergency services are assumed to be inoperable, located in the very target zones that were just destroyed. There is no help coming. Survival is a battle of waiting. Radiation decays exponentially. A rule of thumb suggests that after 7 hours, radiation levels drop by 90%. After 48 to 72 hours, they can drop by 99%. This is the first survival filter. Phase 3, 1 to 12 months. The collapse. As survivors emerge, they face the second-order collapse. The electromagnetic pulse, EMP, from high-altitude bursts has fried electrical grids. The internet is gone. Communications are impossible. Global supply chains are severed. With no power, no running water, and no food deliveries, society begins to disintegrate. Phase 4, 1 to 10. Years, the famine. This is when the real apocalypse begins. The long night of the nuclear winter. The bombs kill millions. The soot kills billions. This is the mechanism of nuclear winter. The 100-plus firestorms over burning cities and industrial areas inject millions of tons of black, sooty smoke into the stratosphere, 10 to 15 kilometers up. This smoke is above the rain, so it isn't washed out. It absorbs sunlight, heats itself, and rises, spreading globally. It forms a blanket of soot that will shroud the planet for years. This blanket plunges the Earth into a severe, prolonged global cooling. A full-scale war between the US and Russia could drop average global temperatures by more than 5 degrees Celsius, a climatic change greater than the last ice age. The result is global famine. The cold, dark, and dry conditions make agriculture impossible. The numbers are difficult to comprehend. A limited regional war between India and Pakistan, using less than 3% of the world's arsenals, is projected to cause crop failures so severe they would kill up to 2 billion people from starvation. A full-scale war between the US and Russia would, according to one model, kill an estimated 5 billion people from famine. Most of these deaths will not be in the countries fighting the war. They will be in the non-combatant nations of the global south, whose food chains have utterly collapsed. Finally, the economic collapse. Our modern just-in-time global economy is optimized for efficiency, not resilience. Studies show that destroying just 3% of global industrial infrastructure, a fraction of what would be hit in a US-Russia exchange, would trigger cascading failures through supply chains, reducing global industrial output by 25%. Our system is too fragile to survive the shock. The risk map is stark. The entire northern hemisphere is the primary target zone. This includes all of Russia, the United States, and Europe, as US nuclear weapons are also stored in 5 NATO countries: Belgium, Germany, Italy, the Netherlands, and Turkey. But the most vulnerable are not just nations, they are populations. Urban centers are death traps. They are the primary targets, both for their military value and to maximize civilian casualties. They are 100% dependent on the fragile supply chains for food, water, and power. And in the cruelest irony, their medical infrastructure, the hospitals and trauma centers, will be vaporized in the same instant as the people they are meant to save, rendering them essentially inoperable. So, where is safe? The answer inverts our idea of power. The safest nations are not the most developed, but the most isolated and agriculturally self-sufficient. Studies consistently name Australia and New Zealand as the nations best placed to survive and help reboot human civilization. tucked away in the southern hemisphere. With robust food production, they could potentially feed their own populations even in a nuclear winter. The key to survival is not military might. It is geography and calories. If the worst happens, what is the plan? Humanity is pursuing several distinct strategies for resilience. Case study 1. Saving the people. Switzerland has pursued a unique strategy of total population defense. It is the only country in the world with a law guaranteeing a nuclear, biological, and chemical-sealed bunker space for every single citizen. They have approximately 370,000 bunkers, providing more than 100% population coverage. These range from private shelters in residential basements to massive, secret government command centers like the K-20 bunker. The goal is to get the population through the initial fallout crisis. Case study 2. Saving the foundations. But bunkers are useless if survivors emerge to a world without food. Deep in the Arctic permafrost of Norway lies the Svalbard Global Seed Vault. It is the ultimate backup. An agricultural save file for humanity. It holds duplicates of over 3 million seed samples from nearly every country and gene bank on Earth. Its purpose is to safeguard our crop diversity against any catastrophe, war, poor management, or climate change, ensuring we have the genetic material to restart agriculture. Case study: a confession of fears. A nation's strategic stockpile reveals its deepest anxieties. The United States maintains a massive strategic petroleum reserve, hundreds of millions of barrels of crude oil, to ensure its economy and military can continue to function. It does not, however, maintain a strategic food reserve. In stark contrast, China, a nation with a deep cultural memory of famine, maintains a massive, state-secret strategic grain reserve. Managed by the state-owned Sinogrown, its warehouse capacity exceeds 700 million tons. Its priority is not economic continuity, but social stability and subsistence. But what is the true condition for a reboot? We have become a society of consumers rather than makers. The seeds in Svalbard are useless if no one remembers how to farm without GPS-guided tractors and chemical fertilizers. True knowledge is not just data in a book. It is embodied in people with skills: the farmer, the engineer, the doctor, the teacher. The real key to resilience is preserving not just things, but us, and the social networks that allow us to learn. We're living in the shadow of 2 clocks. The first is the Doomsday Clock, a symbol of our capacity for self-destruction. Its hands now frozen at 89 seconds to midnight. It represents our failure of stewardship. But another clock is being built. Deep inside a mountain in West Texas, the 10,000-year clock is being assembled by the Long Now Foundation. It is an immense mechanical monument, engineered to keep accurate time for the next 10 millennia. It is designed to tick once a day, and to ring its chimes in a different sequence every day for 10,000 years. It is an implicit statement of optimism. A profound challenge to think on the scale of generations, to ask ourselves if we are being good ancestors. The scenarios in this video are not science fiction. They are the calculated, peer-reviewed consequences of the systems we have built. The ultimate solution is not to build a better bunker, but to build a better world. The 1991 reversal to 17 minutes to midnight is the historical proof that diplomacy, treaties, and human cooperation work. The bombs are the threat, but the choice is ours. The question is not, How do we survive the apocalypse? The question is, which clock will we choose to listen to?